Okay, we proceed. Now that is, we have talked about that the first lesson about ethane. Now and so about propene, you can do propene. Now I want to use propene. Then you see how we can also have skeletal formula. Propane. Now that's ethane, the second hydrocarbon. The third hydrocarbon is propane. Propane. What is the molecular formula of propane? Propane is having 3 carbon atoms. So C3H8. This one can be this one. In fact, this is this one is molecular. Actually, sorry, this one. I tell the first lesson we said this molecular formula. This one is not molecular, but this is called condensed formula. This one CH3 is called condensed formula. Yes, but for the molecular formula is C2H6, Cr2 1 2, then Hr3 plus 3 6. So C2H, the first one for ethane, C2H6. So C2H6, that is molecular formula. Then if you talk about condensed formula, is this one, CH3CH3. That is condensed formula. Yes. Now, what about propane? Propane, C3H8. This is molecular formula. C3H8. It has 3 carbons. 3. Hydrogen are 8. That's molecular formula. What about now open structural formula? Open. Now open is C. There are 3 now. Carbons are 3. Then the rest are hydrogen. How many hydrogens? 8. Give this one hydrogen. Give this 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 hydrogen. And give this hydrogen. So, how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. Then confirm. Is carbon atom surrounded by 4 bonds? Yes. 1, 2, 3, 4 for this. 1, 2, 3, 4 for this. 1, 2, 3, 4. That one must be a must. This one is called open structural formula. But this one is called molecular formula. What about condensed formula? Condensed formula is CH3, the first one, CH3, then CH2, begin CH3, CHR3, then CHR2, then lastly CH3. This one is called condensed formula. Right. That's like a propane. Now this propane, now we can develop skeletal formula. Now we talk about carbons. That's skeletal formula. The first carbon, second, third. Like we have C3H8. How many carbons are there? 3. So the first carbon, second carbon, third carbon. So first carbon, second carbon, third carbon. For propane is if it is butane having C4H10 is now the first carbon, second carbon, third carbon, fourth carbon. These are called now skeletal formula. For it can only start from propane, but it cannot start from ethane because the first, second, third. For the butane, first, second, third, fourth. For propane will be first, second, third, fourth, fifth. Right? So these dots is for carbons. Right? The skeletal formula. Now, what is the general formula for you to know how to write this thing? The general formula of alkanes. General formula of alkanes is this. So general formula CnH2n plus 2. CnH2n plus 2. That is the general formula for all alkanes. Right? Now, if you want to develop, like let's say I want to talk about pentane. Pent means 5. Pentane, 5 carbons. So pentane, from the formula, general formula, as a general formula. Now, how do you do pentane? Pentane means 5 carbon. So C will be N. So this N is equal to number of carbon atoms. N in this case refers to number of carbon atoms, and the formula CnH2n plus 2. Now, N, if it is 5, number of carbon atoms, let's say there are 5, right? H2n, 2n meaning 2 times n, 2 times 5, n is 5. If n is equal to 5, n is 5, so n times 2, 5 times 2, which is 10, right? 10 plus 2, 12. So 10 plus 2, 12. So C5H12. So you see how you will know the number of hydrogens are there. Like if you are talking about pentane, 12 hydrogens. Because I know the formula, CnH2n plus 2. Okay. Now, what about decane? Decane. So pentane, octane, decane. Now decane, dec means 10. If I talk octane, oct means 8 carbons. If I talk about nonane, non means 9. If I talk about hex means 6. If I talk about hept means 7. If I talk about bute means 4. So you must know this one. Decane, let's say n is 10. If n is equal to 10, then C10, then H 10 times 2, 2n, H times 2, 10 times 2, which is 20, plus 2, 22. Meaning, hydrogen will be 22. How do you draw that one? C will be 10 now. Remember, I still talking about hydrocarbon alkane. 1, 2, 3, 4, 5, 6. 1. So let me put 1 here. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10. Then the rest will be hydrogen. The rest, all of them. Remember, make sure that your carbons are surrounded by 4 bonds. Must be surrounded by 4 bonds. Must be surrounded by 4 bonds. Must be surrounded by 4 bonds. These are all hydrogen. But up to there, maybe just my body is not. Okay. So this one, like this one. The first carbon, 1, 2, 3, 4. Second, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. You must make sure that carbon is surrounded by 4 bonds, right? So you know how you can develop alkanes using the formula, right? So if you have a question there, my friend, ask, because you are in a business of doing the exams. Okay. Then maybe today, because we are still under nomenclature, we want to talk about something called isomerism in alkane. Isomerism. So what's isomer? Isomers are compound having same molecular formula but different structural formula. So isomers, isomerism. What's isomers? What are isomers? Isomers are compounds having same molecular formula but different structural formula. Same molecular formula but different structural formula. Apart from after isomerism, okay. So we have same molecular formula but different structural formula. Now I told you go and look about the meaning of molecular formula and structural formula. Okay, the meaning, the two differences. Now, what are some examples of isomers? Like for example, if I have methane, remember we are still under alkane. Methane. This is methane. Now its isomer will be methyl. Methyl is now its isomer. Now for methane is written CH4. Now the alkyl, we talk about alkyl group. The alkyl, it will form an alkyl group. They have same molecular formula but different structure form. So same molecular but structure different. So like methane can form an alkyl. So CH4. So when it forms an alkyl group, it will only lose only one hydrogen. Only one. So CH4 it will be CH3. Only one hydrogen is going. So it's very easy for you to know that. That is the strategy used to. So it will be CH3. So this is methyl. Methyl. We're going to see how these ones are applied even in naming methyl. So you have CH4 to CH3, losing only one hydrogen. Ibaki CH3. CH4 ibaki CH3, right? You may lose nini one hydrogen. So methane, methyl. Methane, methyl. So it's called methyl after losing one hydrogen. So methyl groups. Now what about ethane? Ethane. Ethane is second hydrocarbon or second alkane, which is C2H6, right? C2H6. You know how the formula, how it is. You know the formula. C2H6. Now it will lose one hydrogen to form an alkyl group. It's some alkyl group. So it will be C2H5. C2H5. So this one is ethane. So this is called ethyl. Ethyl. C2H5. Ethyl. And this C2H5 can also be written as CH3 CH2. So CH2 CH3. CH2 CH3 same as this one is same as C2H5. Why? Because C are 2, H are still 5. 2 plus 3 5. CH2 CH3. Sometimes they can read it in this way. It's still an ethyl. Ethyl. So losing one hydrogen. So if they lose one hydrogen, they form the alkyl group. What about for a case of what about for, like for example say butane. Butane is C4. Butane C4H10. Look at the formula, how it is. So C4H10, that is butane. If from the alkyl group, it will be C4H9. Losing one hydrogen. So this is butyl. Propane is C3H8. Then losing one hydrogen will be C3H7. This is now propyl. So that is their corresponding alkyl groups. That one you must know. No shortcut. Right. I hope you are getting me right. Now, lastly, that I want you to know today is and this assignment. After that, we'll go to assignment. Rules of naming. Okay. In naming, wait a bit. Come back now. In naming, these are the rules that you must know. Now, nomenclature of alkanes. The first rule says identify the longest chain of the carbon of that continuous carbon and name its parent alkane. Identify the longest chain. Identify first the longest chain. After identifying the longest chain, then name it. Give it a name. Okay. For example, we have say 3, say 2, say 2, say 3, say 3. So we have, for example, this one. Let me just give you an example that I know. So the rules, so nomenclature rules. So let's say we have CH3, CH, CH2, CH3. This will be 1. Okay, I'll see. Then maybe, yeah, then I have a CH3. Okay. How can you write this? This is like condensed formula. This one you have been given maybe exam, condensed formula. Condensed formula. How can you write the, like maybe open structural formula of this one? Open, can you do open? Or can you do molecular formula? So this one, like you can even write its molecular formula, like so this is like open. Open, if you want to come up with open, then we have C, the first one. So C, HR3 is open. Then sorry, HR3, say 1, 2, 3. Then we have this carbon, H is so here H1, C1, 2, 3, 4, 1, 2, 3, 4. Then here we have this H, we put it here. Then down we have CH3. And what is CH3? Methyl, because one hydrogen is gone. So it's called, it's in a baki methyl, from methane, so methyl. This is methyl. Sasa hii hydrogen hii hapa unaona hapa hii ndio hii. Right? So this is just then this hydrogen, these are two. There are two here. The first one comes here, second comes here. Then this one, there are 3. Yes, imeingia. So this is open. Right? This carbon atom is surrounded by open bonds. 1, 2, 3, 4. What about this one? 1, 2, 3, 4. What about this? 1, 2, 3, 4. What about this? 1, 2, 3, 4. So to make confirm iko sawa. Okay. After confirming that, we want to talk about rules of naming. Now we have this one. We have this CH3, CH, CH2, CH3, apa CH3. If you do this open, then utaona ni kila kitu hapa iko sawa. Hii iko sawa. Right? Discuss it the way nimesema. Umeona vile nimetoa hiyo open. Now, what is the first rule? Identify the longest chain and give it a parent name. The longest chain here, 1, 2, 3, 4. Then we also have 1, 2, 3, 4. Then we have 1, 2, 3. 1, 2, 3. Identify the longest chain of carbon atoms only. We're only looking at carbon atoms. So the first carbon, 1, 2, 3. That is shorter. Look at this one. 1, 2, 3, 4. That's longer. Or 1, 2, 3, 4. That's also longer. Meaning, the longest chain here is 4. And what's the name of 4? Butane. Butane. So the first rule, identify the longest chain and give it common. What is the name now? Because 4, it's the longest 4. Now the parent name, butane. That is parent name. Parent name. Parent name is called now butane because longest chain is a butane. 4. Butane. Okay. Number 2. Number the longest chain from the end to the chain that is near to the branching. Rule 2. I want to number this, giving it number 1, 2, 3, 4, from starting from the point where it is near, branching is near. Okay, that wasting time. Now, this I can name this one like 1, 2, 3, 4, but I must follow that rule where I name it where branching is near. This branch is here. 1, nikitoka hapa nimeingia hapa branch, nimeingia branch. Lakini nikianza na huku itakuja 1, 2, 3. Sasa tatu ndio kuna branch. The third carbon ndio kuna branch. Lakini nikianza hapa 1, 2, the second one kuna branch. So siwezi anza huku ati 1, 2, 3 because hii itakuwa the branch itakuwa number 3 na 3 sasa ni kubwa. Sasa nitaanza lazima nianze huku. I must start this side as per that rule. So I start 1, 2, 3, 4. That's what I cannot put 1, 2, 3, 4 because sasa hapa itakuwa number 3 which ita change the name. Kama hii branch ingekuwa hapa then ningeanza huku, huwezi anza huku. Let's say hii branch hii 3 the method ingekuwa hapa. So itakuwa 1, 2, 3, 4. So ningeanza na naming this side sio huku. So the rule is that where this branch, that's where you start from. Second rule. So I give it from here 1, 2 because the list is 2, 3, 4. Ingekuwa hapa ningeanza huku. I hope you are getting me. So this second rule. Third rule. In case there are 2 more or more similar subsequent groups in the chain, they are indicated by the prefixes di, tri, tetra, commas, etc. In case there are more than 2 subsequent groups, right?